My name is Matt Jordan. This is James Tong, and we're both architects in our Chief Technology Office at Vanguard. And we're both part of a platform team that is responsible for our event-driven platforms. So we are an AWS shop. So we do, so when you think about AWS services, that's your Kinesis, Firehose, EventBridge, SNS, SQS. We are looking at the managed service for Apache Flink. And then we also own the Confluent Cloud platform, which is what we're going to talk most about today. So some things that just to kind of touch on the agenda, brief overview of who Vanguard is, in case you're not aware. We'll talk about a modernization journey that we've been on the past few years, how we chose Kafka and Confluent Cloud, how that fits the use case. We'll talk about the modernized trade path, so an overview of a very specific mission-critical use case. We'll talk about the current state of our platform, so kind of where we are. We're two and a half years in. Some lessons learned with what we've learned as a platform team supporting this type of platform. And then also just some future enhancements that we're looking to adopt probably over the next year to year and a half. So Vanguard is one of the world's largest investment companies, offering a large selection of low-cost mutual funds, ETFs, advice, and other related services. So we've got about $9.5 trillion in assets under management, over 50 million clients worldwide, 423 funds, and then we've got about 16 global offices, obviously throughout the world. So with this type of company, thinking about the type of scale that we're operating, with, there is a lot that goes into supporting our applications on a daily basis. So over the past few years, we have been re-architecting, re-platforming, modernizing a lot of those applications, moving them into, from an on-prem environment to more of a cloud environment. So now I'll turn it over to James to talk through a little bit about how we've leveraged Confluent Cloud and Kafka in those modernization efforts.
Thank you, Matt. So let's set the context on how Vanguard started using Confluent Cloud and our Kafka journey. So about as recently as a decade ago, many of Vanguard's applications were monolith applications running in our on-premise data center, as Matt mentioned. Many of these applications made up our largest websites and often had monthly or even quarterly release cycles. So Vanguard IT's modernization journey really started around 2015 when we adopted a couple of significant cultural changes, the first of which was strangling the monolith into microservices, adopting Spring Boot and other microservices frameworks. We also started adopting continuous delivery. We had adopted continuous integration a couple of years earlier, but the ability to deploy at the scale and leverage technologies such as containerization really enabled us to grant that continuous delivery benefit of agile delivery. In addition, we started with a hybrid cloud platform across our on-premise data center as well as in AWS. A couple of years later on, we decided to pivot and move all in on AWS as our public cloud provider. While we were making these changes, we were also building additional shift-left capabilities into our continuous delivery pipeline. So shift-left, of course, being one of the themes from this year's conference. But the shift-left I'm referring to, of course, speaking to the DevOps, or more specifically DevSecOps mentality of shifting testing and quality gates, et cetera, left into the CD pipeline. So as we started adopting AWS in more applications and business processes, we naturally saw a significant growth in our use of AWS event-driven services. As Matt mentioned, SNS, SQS, Kinesis, EventBridge, Lambdas, of course, as well. So we'll talk a little bit about how we got to Kafka and Confluent Cloud in a moment on the next slide. But specifically, our team was formed in 2022. And as Matt mentioned, we were responsible for rolling out Confluent Cloud after we did an evaluation. And so that brings us to where we are today. We're about 3 years into our Kafka and Confluent Cloud journey. We have quite a bit more experience and more applications and business processes that are leveraging the AWS event-driven services. And so you'll see how that has shaped our direction going forward. So a couple of years ago, as is commonly the case, one of our largest divisions was doing multi-year planning. This is our personal investor business, our retail direct business as an individual investor. If you want to open up an account and trade securities, that's the business that I'm referring to here. So specifically, the two main areas that they were looking to modernize was their trade or order modernization path, as well as what we call our client experience 360, otherwise known as hyper-personalization programs. So at this point, of course, we had already leveraged a lot of the benefits of continuous delivery, of AWS event-driven services, but we were starting to run into some challenges, especially with scaling and with performance with some of these services. And as they were trying to figure out what was the right technology strategy for these multi-year programs, we had a couple of architects and stakeholders who were familiar with and had used Kafka at some other fintech startups. And that helped, along with some of the challenges that we were facing with the AWS event-driven services, really push the ball forward in bringing in Kafka into Vanguard. And so the evaluation of Confluent and Confluent Cloud specifically versus MSK, for a number of reasons that we'll get into in a moment here, we ended up choosing Confluent Cloud. These two programs, the trade modernization as well as the hyper-personalization or client experience modernization, are really mission critical, large volume, large scale. And so that was partly one of the reasons why Confluent Cloud was chosen. In general, and we've heard it from the keynotes as well, companies like Mercedes-Benz and GeoConnect, the focus of our IT is really on delivering business value to our clients and our customers. And so the more fully managed offerings appeal more to us, because that way we don't have to think about underlying infrastructure changes, cluster upgrades, Zookeeper to Craft migration, for example. We'd rather spend a little bit more and delegate that work to our SaaS vendor rather than deal with that ourselves. So cluster maintenance, all of those aspects, it's the same with us as well. So talking a little bit about Kafka Connect. So Confluent offers a large variety or catalog of connectors that we also felt added value in our decision-making of why to go with Confluent Cloud. While we mentioned fully managed source and sync connectors, we actually have started with self-managed connectors. So we operate AWS clusters, and we are using private link connections. So some of you may be aware that Confluent earlier this year enabled egress access points that enables fully managed connectors to use private networking to connect to your AWS accounts for source and sync connectors. So right now, we still have not rolled that out yet. So today, all of our connectors are actually running in ECS, and we are in the process of setting up egress access points so we can migrate later on to use fully managed source and sync connectors. In addition, about a month ago, we started leveraging Confluent's Flink offering, so to support our streaming use cases and streaming applications, particularly with these significant data products or domain areas of hyper-personalization and our trading platform. And so that way, we can build on top of these data products and really leverage the power of streaming applications. So we are really looking forward to using and leveraging both of these fully managed offerings from Confluent Cloud going forward. So next, we'll go into our modernized trade path overview here. So you'll see Confluent Cloud in the middle here. I'll get into that in a second. But the broader scope of this is that we were looking to migrate from our legacy trading platform, which was still running primarily out of monolith applications on-premise, as well as a centralized monolithic database. And so we still have to run our business while we're iteratively building and migrating parts of this workflow to a fully cloud-native distributed platform. And so that really begins in the top left corner with our serverless front ends running at the edge, close to the clients. Then we have our microservices represented by some ECS applications that are supporting our trade orchestration and validation processes. We have Confluent Cloud topics that are used for outbound trades as well as inbound trades. And then we have our event-based market routing platform. So the trade routing applications here are referring to basically making that decision on which of the dozen or so market makers or market centers that we use for executing the trades would get routed to. And the communication between our trade routing applications and the market centers is through the Financial Information Exchange or FIX protocol. And we'll get into that in a minute when it comes to disaster recovery, multi-region, active-active types of concerns. Once a trade has been executed, then the trade state, I should say, is Aurora database that's stored, as you can see there. The trade, then for post-trade processing, there's a number of applications that are used for such activities as client notifications, for canceling options, and updating cost basis accounting, as an example. So in a nutshell, that's the overview of the modernized trade path. So the goals and what we're trying to achieve through this, again, a large part of it is really moving away from our legacy on-premise applications, monolith applications, and database. But also, it is to significantly improve our scalability and resiliency. So being able to scale to as much as 100 times the current trade volumes, being able to improve our client journey success rates. So we're speaking about the ability of our clients to go through the trade process successfully. Of course, we have client satisfaction scores that we calculate as well. And we really want to be able to speed up that time to market in terms of delivery. And so by leveraging, in part, Confluent Cloud for our event-based market routing platform as part of this larger modernization of our trade path, we have really been able to see a lot of the benefits that we were going for. So this started with the ETF trades, and earlier this year, we were able to successfully complete our first mutual fund trade. I believe it was a $5 trade of the Vanguard 500 index fund using this fully cloud-native and distributed trade path. So next, let's spend a little bit talking about some of the lessons learned or some of the challenges we faced when it comes to figuring out how to make this as resilient and as highly available as possible. And so we're talking about multi-region or active-active or failover. So a little bit of the basics. I'm sure many of you are already aware. There's trade-offs in terms of the deployment patterns for high availability. You're basically trading off availability versus cost and complexity of the architecture, a number of different patterns for active-passive. There's no one-size-fits-all, of course. It really depends on the application as well as the criticality and the RTO or RPO, recovery time objective or recovery point objective for each use case. So RTO being the max time to recover, RPO being the max data loss that you're willing to accept. So when it comes to our modernized trade path, we're still running the business in part off of the legacy on-premise trade path. And so that factors into how quickly we can toggle between the cloud-native distributed trade path and the monolith trade path. And in addition, we, of course, have contingencies, alternative trade paths. So that really is a consideration to keep in mind for your specific use cases. So as an example, going back one slide here, that Route 53 reference, so we have health checks, multi-region health checks, that will identify if our trade orchestration and validation applications become unavailable. We are running out of US East 1 as our primary region and US West 2 as our secondary region. So our trade orchestration and validation applications being standard HTTP or web-facing microservices, We have these health checks that will determine if the application becomes unavailable in US East 1 and automatically route the weighted routing to US West 2. The trade state, as I mentioned, is being stored in an Aurora database. So, for example, we have to consider if the ECS applications become unavailable, what is the correct action in that case? Since the trade state is stored in Aurora and we want to maintain as much of the correctness as possible when it comes to low latency, risk of duplication, idempotency concerns, we also want to try to preserve as much of sequential ordering as possible. Whichever trades were submitted first need to be processed first. So as an example, if the ECS applications were to become unavailable for the trade orchestration applications, but Aurora and Kafka remain available in US East 1, while the trade will come into those applications in US West 2, they're actually going to do a cross-region production or publishing of events to the outbound trade topic in the US East 1 cluster, again, to try to preserve as much of that as possible. If, of course, there are other failure scenarios that we have to plan for, if that Aurora instance goes down in US East 1 and we have to fail over the writer instance to US West 2, then that is a completely different scenario, but that's an example of some of the planning that we've done. The trade orchestration and validation application being active-active, that is certainly one piece of it, but we also have to look at the downstream impact. So I mentioned the FIX protocol that we use to communicate the securities transactions between our trade routing applications and the market centers earlier. So the FIX protocol being a couple decades old, for example, there's some IP restrictions. There's some restrictions on sequential ordering of messages between the source, the trading application, and the market center as well. And so for those reasons, the trading route applications actually are active-passive. And so we've run into some interesting scenarios that we've had to deal with in making sure that both sides are aware, because these are different teams, communication, notifications, awareness, if there is a failover, if there is a need for the trade routing applications to consume from a mirror topic, for example, and I'm jumping ahead a little bit into cluster linking here. So all of those still apply. The communications, notifications, awareness of these disaster recovery or failover scenarios. Some of this is not technology-driven, it's just human communication and process-driven. So as I mentioned, we're using AWS dedicated clusters in Confluent Cloud and with Private Link, and we're using Confluent Cloud's cluster linking capability. That's the diagram on the right here for those who may not be familiar with it. So it automatically will migrate the consumer offsets and up the messages between our source and destination clusters, particularly in this case between US East 1 as our primary and US West 2 as our secondary regions. So the trade routing applications to try to preserve that ordering, as an example, when the consumer starts up, it is actually trying to identify if there is consumer lag on the mirror topic in that region, whichever region it starts up in. And if it is a non-zero consumer lag, then again, to preserve that ordering, it is trying to process those outstanding messages before it unsubscribes and subscribes to the read-write topic in the local region, in the local cluster that it's connecting to. So we've run into, again, some interesting scenarios with that. Again, we're in year 3, so this is also not fully completed or defined yet in the sense that we're still doing testing and we're still doing these failover tests, making sure about correctness as much as possible, trying to sort out any edge cases. So the other piece that I'll mention is that we are using regional topic names. So those of you who are familiar with cluster linking probably are familiar with the failover and promote patterns. If you use a single topic name across both regions or both clusters. And we've decided to go with separate topics and regional topic names, and that also has influenced our design a little bit. All right, so with that said, again, it's still very much a work in progress, but we feel pretty confident so far in that we can move forward, and we have already seen the first mutual fund trade that was processed earlier this year, so we'll slowly begin incrementing and rolling out this a little bit more broadly. So with that said, I'll turn it back over to Matt, who will go into a little bit more about our current state, current usage of Confluent Cloud, some of the features that we're looking into, and some of the lessons learned as well.
All right, so I'm going to share some numbers with you. As we've mentioned, 2.5, 3 years, 3-year journey with Kafka, kind of from that very beginning to where we are today. So these numbers, we'll kind of start from left to right, but right now we've got just over 90 applications, so both producing and consuming events from Confluent Cloud in Kafka. About 20 million messages per day. So if you're at the Netflix talk yesterday, that's not a lot. But from the way that we have rolled out Kafka, the way that we have started gaining adoption, this is still a starting point for us. This is still very early on in that journey. And then that 20 million messages per day, that equates to about 10 gigabytes worth of data. So I think you've got some of that per second in other organizations. But the growth and adoption that we've seen on this platform has been 100% year over year. So when you look at once teams understand how they can integrate with this platform and then what it can actually do for them, we're seeing that adoption rapidly happen. In those 90 applications, it's probably somewhere around, probably 30 to 40 applications are actually producing. And it makes sense that you would see more consumers, right? So with the enhanced fan-out capability that Kafka provides, we obviously see a lot of consumers now kind of plugging in to consume messages from those various topics. So we've talked a lot about this already, but I'll go ahead and highlight a little bit. Obviously, Confluent Cloud. James mentioned we are leveraging dedicated clusters. So if you're familiar with Confluent Cloud, there's a concept of an organization. So an organization is almost like an account. We have organizations at an engineering, at a test, and a production level. And so that means we've got our dedicated clusters set up in an engineering environment, a test environment, and a production environment. We are also set up, as he mentioned, for in US East 1 and US West 2. US West 2 is typically going to be that replication region where we're actually going to be replicating some topics or some messages to topics over in that particular region. And then, of course, that is what teams integrate with if they need to, if and when they need to fail over. He mentioned the self-managed connectors running in ECS. So this is, we'll talk a little bit about this in a few minutes, but there are obviously Confluent images that we're able to bring in to connect to various data sources. There's also open source Docker images as well. And so that is how, we do have teams that do need to connect to on-prem databases, maybe something running in AWS. And so this is typically how teams are going to do that. Obviously, there's a number of producer and consumer applications. They're going to be built with a number of different languages. So we've got Java applications. We do have Python. We do have Node. So we're excited about the kind of the new support for Node that was announced today. We also see, since we are AWS, we do see a lot of Lambda functions that are being used, both as producers and consumers. So when you think about how that can actually be done, we are leveraging, in most cases, the event source mapping that Lambda provides that connects directly with Kafka. And then we do see a number of applications running in ECS and EKS as well. Something that we've been focused on this year is the actual onboarding and the provisioning of resources for our application teams. So that process has been very manual in the past. It's not hard to do, but it is something that is time consuming, and it can be somewhat error prone because we've got individuals naming things, maybe not selecting the correct options. And so we've spent a lot of time on automation. And so there is a Terraform provider that Confluent provides that will provision, if not all the resources, the majority of the resources that are needed when managing this type of platform. We've also built out a number of GitHub workflows that help not only with the automation for creating those resources, but for ensuring, applying various policies to just ensure that they're being provisioned in the way that we would expect. Right now, it's just our team that uses that platform, so it's just our small team of engineers, but we do plan to make this more available for self-service, across the enterprise. And then finally, obviously, observability and monitoring is very important when it comes to operating this type of platform, especially with the type of use case that James kind of walked through. So Confluent Cloud provides a metrics API endpoint that will provide all of the metrics around your Kafka clusters. We also have information coming in about producers and consumers, any consumer lag that may be going on with some of the topics. So there's a lot of really good, robust information that we are ingesting through an open telemetry collector and then exposing that through Grafana. And then we've spent a lot of time also configuring the alerts to help us just understand the health, the overall health of our Confluent Cloud platform. So some lessons learned. I think the first one we call out the core engine, but just thinking about Confluent Cloud and how it has been rebuilt, redesigned for that high level of availability, we've experienced that. So we, our clusters do run on AWS, and we have, hopefully, we have not seen any issues to this point as far as availability is concerned. So as far as our teams being impacted by something, a piece of infrastructure that we don't own, we have not run into that issue just yet. So I think that speaks pretty highly of the core engine. We also like the fact that we don't have to worry about patching. We don't have to worry about upgrades, and we are not impacted by those efforts being done on the Confluent side. Something that is interesting, I did mention the dedicated clusters. So if you remember the tiering, if you're in the keynote yesterday, they talked a little bit about the tiering of some of the different clusters. Dedicated is on that higher end. So right now we are using the lowest level of CKUs, which is 2, in those particular clusters, and we're not even really scratching the surface on utilization. So even with those 90 applications, obviously a small number of messages per day in the grand scheme of things, we're still not utilizing everything that it provides just yet. And then we still have the ability to scale those clusters in the event that we need to, I think by 12 times that particular size. Self-managed connectors, we've hit on this already. Our experience has been they're a little bit difficult to maintain. And I think when you look at our application teams that are already building microservices, web applications, whatever the case may be, they don't want another application that they have to own and maintain. And right now they have to do that. So they have to provision an ECS application. Even though the images are provided, there's a lot of configuration. If something does go wrong, they configure something incorrectly, they're usually having to reach out to our team to help figure out what exactly is going on. So we definitely want to leverage the the fully managed connectors that Confluent is providing, and we are looking to start doing that over the next year or so. Already touched a lot on automation, so I won't spend a lot of time here, but it definitely has simplified the process, and it has enabled teams to, with just speed to market. Even if it's in an engineering or test environment, because there's a lot of proof of concepts going on right now with the different teams, we can get the infrastructure or the resources required up and running very, very quickly for them. Data governance, I don't know how many people are part of another financial service or another financial institution, but data governance is huge. It's a big piece, and as we bring in a new platform or a new service that is a new data source, not everybody at Vanguard's thinking about it like that just yet, but these Kafka topics truly are new data sources. So there's a lot of questions from a data governance perspective. We've put a lot of work into S3, our data warehouses, our other databases. This is now another hot topic at Vanguard. So we've partnered very closely with our data governance teams. We've helped them understand how the controls are set up, Access controls are set up for data through various topics. And then they may even be modifying some of their processes to now account for topics in Confluent Cloud. Last but not least, we'll talk through, just highlight a couple of the future platform enhancements. Schema registry. So if you're not familiar with schema registry, it's obviously a place that you can go out and define your schemas for various topics. This is something that we have teams leveraging today. So it's not something that we haven't used. It is something that we're familiar with using. But what we are looking to do is we are looking to standardize this across the enterprise. And we also want to have teams be able to self-provision their own schemas in schema registry. So today, that is a little bit more of a manual process. It kind of comes through our team to get that set up. We are still thinking through event specification. Some of you may be familiar with async API. There's cloud events. There's a number of different ways to document your API or your event specifications. We're still trying to figure out at an enterprise level what is the what's going to be the right solution for that. And then event cataloging as well. We do use Calibra for the majority of the databases and tables in our data lake, but we're still trying to figure out if that's going to be the right place. It may or may not be, but those are all still things that we're working through. My favorite topic is the real-time stream processing, which has been a theme. This was not planned, but it's definitely been a theme over the last couple of days. And so we're very excited about adopting Confluent Flink and really taking most of which is notification, so events as notification today, I think when you look at most of the implementations, and really expanding that out to where we can answer a lot of real business questions by looking at multiple event streams. So we've been looking at automation, been looking at what it would look like to again allow teams or enable teams to self-provision Flink statements. Obviously, we will probably be be responsible for the compute pools, but we're still trying to figure out what exactly that's going to look like to scale across hundreds, if not thousands, of development teams. Already mentioned the fully managed connectors, automation enhancements. I think we'll continue on that. And the last one is going to be table flow enablement. So this is where I think we do have an organization, our Chief Data and Analytics Office, they are mostly responsible for all of the ingestion pipelines and all of that into the data lake. Now we have, and I will say from a data lake perspective, we are leveraging Iceberg tables, so most of which is in S3. And so this is going to complement what has already been built over the last few years as we bring in this new platform, having table flow to take some of the topics, convert them into Iceberg tables, and then sync them to S3 into our data lake is going to be pretty powerful. So we've got a number of data engineers that have already been reaching out, have already been asking questions. Hey, when is this available? And so we are excited. Probably early next year, we will really be diving deep into what it's going to mean for us to enable table flow. So I will turn it back over to James to talk through one last use case that we're excited to share, hopefully in a future session.
Thanks, Matt. So besides the trading platform modernization journey that we've talked through, we wanted to end by giving a little bit of a preview of the other personal investor use cases that we're looking at right now. Might come back and do another talk later on about these. The first is a near real-time client activity feed. So basically taking all of the client activity that they do on our website or through our app and really building a unified omni-channel client experience. And so an example of that would be all of the logons, open account activities, trading activities across the different channels, across your different devices, and being able to feed that into a ledger or an activity feed. So as an example, let's say you are trying to open an account with Vanguard. You start on your laptop, and then later on you realize, I have to go pick up my child from school. So then you go pick up your child, and maybe you're waiting for your child to get out of class or some activity, and you decide, I'd like to switch to my mobile device and go back to where I left off. Today, unfortunately, that is not a unified or a seamless experience. But if we are able to achieve some of the goals that we have with this client activity feed, that could be possible in the future. You can pick up right where you left off across different devices or different channels. In addition, by tracking some of this activity with the clients, we can also feed it for such use cases as fraud detection and for downstream analytics purposes as well. The second use case is really around a decision engine and trying to provide client nudges. And when I say client nudges, it's really leveraging our client experience to give our individual investors the best chance of success, which is ultimately why we're here. So on the left side here, starting with producers, so it's identifying possible client actions across different domain areas, so wealth management or advice. We feed that into a decision engine which leverages machine learning, applies some rules to those, and can calculate a personalized value of the actions that the client could take. And then from those possible actions, we can determine the appropriate places to put client nudges. So an example would be if you log on to your account and you hit our secure overview page, then there could be a banner or a spot on that page where we'll display a personalized message. So as an example, we have hundreds of thousands of clients who have all of their investable assets at Vanguard in effectively a settlement fund or a money market fund. So for example, they may have just opened an account or they may have just rolled over an account from a different provider, and they may not realize that all of their money is sitting in effectively cash. And obviously that has a huge opportunity or potential to improve client outcomes, to give them their best chance of hitting their investment targets. So one of the examples that we have leveraged this for is to provide a banner on our secure overview page that will nudge them to say, hey, it's great that you have all of this money that you've transferred into Vanguard, but there's one more step you need to take, and that's really to put in an investment and be able to hit your goals. And through this type of client nudge, as an example, we have been able to see a significant increase in the number of clients that have acted upon that type of a nudge. So I think we hit around 30% of clients invested within 30 days. And again, that's an example of generating hundreds of millions of dollars in client value over a couple of years. And so that is really an example of the type of real-time or near real-time decision engine and client nudge that we want to continue to leverage. And by using Confluent Cloud and all of the capabilities that we've discussed today, we feel like this is really putting us in a good position going forward. So again, we may come back and go into a little bit this in deeper dive in the future, but hopefully that gives you an idea of how Vanguard is using Confluent Cloud, Kafka, and more importantly, our modernization journey, especially with our trade path. And with that, we'll go ahead and wrap it up and take any questions. Thank you for listening.